In this video, I want to have a look at how, if we're given one trig function, we can find the value of another. So we're going to jump straight into a few examples. So our first one says, given sine theta is 1/5, find cos theta. We're going to start off by drawing ourselves a little diagram. So if we've got sine theta is 1/5, we know that sine is positive, which means that we're going to be in either our first quadrant or our second quadrant. So we're drawing in those angles. Then we're going to form little triangles. So we know sine is 1/5. That has to be our opposite over hypotenuse. So we draw our little triangle in here. We'll have 1/5. Or if it's over this side, we'll have 1 and 5. So we can then use that, if these are our thetas, we can use that to find cos theta. But cos is adjacent over hypotenuse, which means that we need to know the length of this side here. So I'm going to draw this triangle separately. So we've got a right angle triangle there, side length of 1 and 5, and we're going to find this side length here. So let's call it x. We know that x squared plus 1 squared is equal to 5 squared, so that's Pythagoras' theorem, which means that x squared is equal to 5 squared minus 1 squared, which will give us 24. So that means the length of that side is the square root of 24. And if we simplify that, 24 can be broken down into 4 and 6. And we know that the square root of 4 is 2. So we're going to have 2 root 6. So that means, if we put our little all stations to central on here, that cos theta could be equal, if we're looking at this one, cos is positive here, so we could have adjacent over hypotenuse. So 2 root 6/5, or cos theta, if we're looking in this quadrant over here, cos is negative, so we could have minus 2 root 6/5. Right, let's have a look at a second example. Our second example says if tan theta is equal to minus 2/5 and cos theta is less than 0, find sine theta. So we're going to draw a little diagram again. Now we know we've got all stations to central. In our question, we're told that tan is minus 2/5. So tan is negative in this quadrant and this quadrant. But we're also told that cos theta is less than 0. So that means we need cos to be negative as well, which means it's not going to be in that one. We're only looking at one quadrant for this question. So it's got to be when tan and cos are both negative. So we'll draw in our array, make our right angled triangle. Now tan is opposite over adjacent, so that's going to be our 2 here and our square root of 5. So we're going to draw that triangle underneath and use Pythagoras' theorem again. We've got our right angled triangle 2 and the square root of 5. We'll call this one x. So we're going to have x squared is equal to 2 squared plus the square root of 5 squared, which is going to be 4 plus 5, which gives us 9. So that means that x is going to be the square root of 9, which is 3. So then to find sine theta, we know that sine is the opposite, so that's our theta in here. It's opposite over hypotenuse. So sine is going to be 2/3. So that's just 2 examples of how if we're given the value of one trig function, we can find the value of either of the others.